Mining engineers, just like any other engineering discipline, help make the world a better place. They do this by designing, innovating, improving, and leading the way on projects, providing us with all the natural resources that enable us to advance as a society. The University of Arizona is one of just 13 American universities to offer a mining engineering degree. The program stems all the way back to the founding of the school and was the very first program to be established here back in 1885. Of course, a lot has changed since then, but one thing that has remained is the program's long tradition of excellence as a leader and innovator in the field. In fact, the program has been consistently ranked as one of the top in the nation year to year. University of Arizona mining engineers make a global impact by solving the critical challenges of extracting non-renewable natural resources, processing them, and turning them into the materials necessary to create the things that we need. Cutting-edge technologies like battery-powered vehicles, solar panels, or life-saving medical devices all rely on mining engineers finding new ways to extract more complex minerals in lower concentrations, developing new technologies, and making sure that the process is done in a safe, socially responsible, environmentally sound, and economically viable manner. The program here at the U of A is designed to give you a strong mining engineering foundation while also allowing you to discover and pursue your own passion. With 4 different focus areas or tracks to choose from, you can really dive into what you find most interesting and take the courses related to that topic. Having been through the program myself, I can tell you that one of the things I found most exciting about it was the plethora of opportunities to gain hands-on experience and get involved. Whether it's working underground at the San Javier Mining Laboratory, or assisting a professor with cutting-edge research, or even working and getting paid as an intern with one of the local mining companies, there's so many ways that you can gain practical experience. Believe me when I say that there are truly so many different career paths a mining engineer can take. Tucson alone is a mining hub surrounded by mines, consultants, and mine technology companies. But the opportunity to extend beyond Tucson as well. Mining engineering careers can take you all over the world, from developing artificial intelligence that can improve a mine's efficiency to working on boosting endangered species near a site. Our graduates work on all sorts of projects all over the world in a wide range of positions and fields. Lastly, being part of this program means being part of a unique and close-knit community. With small faculty to student ratios and fun student clubs and involvement opportunities, not only do you get to find your path, but also make lifelong friends while you're at it.
Hello, I'm Cray Luxbacher, Department Head of Mining and Geological Engineering, and I'm looking forward to talking to you today about our mining engineering programs.
Students are, and always have been, at the heart of University of Arizona's mining engineering programs. Programs that have touched 3 separate centuries. Our department has a legacy of producing leaders for the entire mining industry in this country and abroad, and has been the state of Arizona's sole provider of academic and research programs focused on mineral engineering and non-renewable resources. Throughout this time, our department has been responsible for some of the world's most dynamic innovations in mineral resource development, contributing to the state of Arizona's present position as the nation's most valuable non-fuel mineral production center. Today, Tucson enjoys a special status as the hub of mining technology worldwide, with headquarters and offices of many iconic international companies, such as Caterpillar, Komatsu, and Hexagon Mining, surrounded by multiple world-class mining operations. These tech companies and operations are engaged in designing and operating the largest autonomous systems on the planet. We have all the components of a world-class education and innovation ecosystem, with the university, technology transfer, industry, government, and civil society. The faculty in our department are active in research and technology transfer, with dozens of invention disclosures and startup companies since 2015. This reflects the cutting-edge nature of the research conducted in the mining program and involves collaboration across colleges, on campus, and the industry. So what can you expect from a program that is ranked top 4 in the country? Students, the most important thing is direct, quality interaction with the faculty. We can definitely offer you that. We are a small program, class sizes are no more than 30 or 35, and the faculty in our department care deeply about helping and mentoring the students throughout their studies. Every student is concerned about the cost of education. Our program has the largest endowment in the College of Engineering, and because we are a small program, every student who meets the requirements will receive 1 or more scholarships. Last year, we awarded well over $400,000 in scholarships. Getting practical experience in any engineering field is very important. Mining students have some of the very best paid internships in the world, and they get to travel all over while doing it. Mining summer jobs pay on average between $15 and $22 per hour. Some students are paid as much as $34 per hour. Every semester, we take our students on educational field trips around the country. This year, these trips include visiting state-of-the-art mines around Arizona, a national conference in Denver, and one of our student competition teams plans to travel to Western Australia this spring. Every year, we have students who take advantage of the agreements our department has with other schools in Australia, Canada, South America, and Europe. And they spend 1 or 2 semesters abroad to enjoy other cultures and countries. Our graduates are often offered permanent positions before graduation and are promoted within just a few years. Our placement rate is near 100% at the time of graduation, and our students are highly successful at obtaining internships. In fact, I invite all of our students to come and see me if they have difficulty obtaining a job, and I will personally assist them. Another great perk is that mining engineering is one of the top paying degrees, with starting salaries ranging from $55,000 to $75,000 per year. With a 1,000% projected increase in demand for minerals needed for green energy and future high technologies, there's huge demand for mining engineers. So, do you want to make a difference by making a positive impact on the environment, the society, the United States, and the world? If the answer is yes, then mining engineering could be a great career choice for you because our faculty and students share your interests. Come and visit us at the open house because we're ready to help you achieve your goals.
Hi there, I'm Isabel Barton, Assistant Professor here at the University of Arizona in Mining and Geological Engineering. Not many people know that mining engineering actually exists, but in fact it is at the heart of industry all over the world. If you've ever looked into your computer, your car, your cell phone, or any other electronic device, you've probably seen some metal in it. Just one of the 6 or 7 layers in your smartphone has more than a dozen different metals, and your phone as a whole contains most of the naturally occurring elements in the periodic table. Those elements come from rocks, and we extract them and convert them into usable forms by mining. As mining engineers, our job is to engineer systems that extract the metals, semiconducting elements, and other important materials from the rocks that contain them safely, sustainably, and efficiently. So what do you do as a mining engineer? You help make a high-tech, green-tech future possible. Every time technology advances, it needs more and better materials. Back in medieval times, you only needed 6 or 8 metals to run your most cutting-edge technology. By the 1980s, it took more than that to make a single computer chip. And now, even your average chip needs more than 50 different metals to pack high computing performance into microscopic size. Semiconductors, superconductors, superalloys, all of them call on mining engineers to develop new ways to get new elements out of rocks. And that will only get more important in the future as we get away from fossil fuels. Shifting from a coal-fired power plant to a field of wind turbines uses less fossil fuels to generate power, but it takes more silicon, copper, aluminum, iron, and other metals that can only be obtained by mining. Think about what's in a solar panel. Silicon, framed by aluminum or steel, doped with boron and connected to the grid by lots and lots of copper. So it would be a challenge just to provide the elements that we need to move our society away from fossil fuels. But here is an even bigger challenge. By the end of the 21st century, the world will have almost 11 billion people on it, and non-renewable resources will be closer to running out. But we not only need more metals to move to green energy, developing nations need steel, copper, and concrete to industrialize. So where does that come from? And how do we get all of it without damaging the environment and the climate? Well, mining engineers produce those metals from resources in the earth. First, we find the ores or the metal-bearing rocks wherever they are, Arizona, Africa, Japan, everywhere. We dig them up, separate the minerals that have the metal, and then process them to get a metal into a usable form for engines, batteries, beams, wires, cables, computer chips, and anything else made out of metal. The engineers that we graduate follow one of 4 tracks as they learn the ins and outs of this process. In the mine operations track, students learn how to design an extractive system, a mine, for anything, whether that means digging a mile deep into the earth or starting 18,000 feet above sea level. Our graduates know how to devise a blasting pattern, optimize equipment fleets with hundreds of trucks, shovels, and drills, and move millions of tons of rock each day. While they're students here, they practice at our own student-run San Javier mine. Students on the geomechanics track mix high-tech sensor platforms and computer modeling with tests of rock strength and fracture dynamics. Whether it's a sophisticated 4-dimensional numerical model that shows how an excavation will remain stable, or a drone-mounted laser platform that monitors micron-scale movements in the rock, our geomechanical engineers design and maintain the tunnels, pits, and shafts that keep mines running at the top of the world, the bottom of the ocean, or any place in between. Once the rocks are dug up, the process engineers and extractive metallurgists get the metal out of them. With a mix of pyrometallurgy and electrochemistry, the students on our mineral processing and extractive metallurgy track break apart the rock, isolate the metallic minerals with some very nifty surface chemistry, and then transform them into high-purity metals for copper wires, semiconductors, solar cells, and everything else. We make the metals, alloys, and superalloys that keep the world driving, flying, and connected. This is the best track in the department. I know because I'm one of the professors who teaches on it. And of course, my judgment is totally unbiased. We really are the best track in the department. Sustainability is a word that you hear a lot these days, but what does it really mean? For mining engineers, it means benefiting the environment and society. All through the mining process, we're cleaning up around us. Our sustainability engineers design automated chemical systems to monitor the water quality around mine sites. They work with the agriculture department to breed plants that are tailor-made for sucking metal contaminants out of soils around old historical mine sites. And they work with local communities in Africa, Central America, and everywhere else in the world to help them ensure that they get the benefits from mining. It's all about engineering a system that gets the resources that we need without harming people or the planet. And then there's the long-term future. If we're serious about exploring other planets or developing a lunar base, we can't just ferry all the raw materials that we're going to need from Earth to outer space. We have to develop the technology to source materials from the local environment, whether that's the moon or Mars or an asteroid. That means autonomous robotic mining equipment. That means new techniques for extracting metals without gravity, without water, and without heat. And that's technology that we're already working on here at U of A Mining. That is the challenge of mining engineering. It's the challenge our students and our graduates accept to produce the raw materials that keep society going, to engineer a system that moves our technology and our civilization forward. We provide the materials to boldly go where no one has gone before. Oh, and in case being part of the biggest challenge at the heart of future civilization isn't enough for you, here are our top 5 reasons why you should major in mining engineering. One is hands-on experience in research and in operations. We have our own student-run underground mine, and our students work with state and international mining companies through annual internships to develop the kinds of hands-on skills that they'll need for their careers. Not to mention, mining is one of the most high-tech professions around. No, I'm serious. Quit laughing. I know the instant I say mining, you start thinking of this old geezer with the gold pan and the donkey. Well, that was the height of mining technology about 170 years ago. So it represents the mining engineering of today about like the stagecoach represents the height of mechanical engineering today. If you go to a mine now, you'll see high-performing supercomputers using artificial intelligence to figure out the best way to move millions of tons of rock around and get the metal out of it. You'll see autonomous haul trucks that can carry hundreds of tons of rock each, scooting around the mine roads without a human driver in sight. Oh, and I know we're all supposed to think that that's new, and maybe autonomous vehicles are new to some people, but that driverless autonomous Komatsu haul truck here, that was first introduced by mining in the late 90s. Oh, and have I mentioned that mining engineering pays well? Our graduates consistently have among the highest starting salaries of any engineering profession at the bachelor's level. In 2020, the average starting salary was $62,000 per year, and you can read the figures on the slide here for yourself. And it's not hard to find a job like that. Pre-pandemic, 100% of our students have job offers within 6 months of graduating. And you can work anywhere you want. If that's Baghdad, Arizona, you'll find mining engineering there. Or if you'd rather, you can go to South America, Africa, Asia, Australia, anywhere. The only continent that doesn't have mines and mining engineers is Antarctica. Oh, and don't forget outer space. We're going to need mining engineers there pretty soon, too. And last but not least, you can graduate without debt. The mining engineering department is ranked #1 in the College of Engineering for scholarship money given per student. This academic year, the department alone is giving out more than $400,000 in scholarships. Last year's average worked out to more than $8,000 per year per student. And that doesn't count the many, many scholarships our students also get at the college and university levels, and from mining companies and professional organizations. So there you go. Thousands upon thousands of reasons why you should major in mining engineering. So come talk to me at the Q&A session.
Hi, my name's Katie, and I'm the president of our school's Society for Mining, Metallurgy, and Exploration Student Chapter, or SME for short. Our chapter focuses on professional development help for students in the mining industry. So for example, we help students find jobs and internships, we provide travel both nationally and internationally for conferences and competitions, and we even have lots of social events and a student lounge.
I'm David Rahal. I'm the VP of Competitions. We're here this morning to practice intercollegiate mining games, which is where we compete in old-fashioned methods of mining.
This is a clip of our underground student mine. All students and SME members have the ability to visit. Our intercollegiate mining games team also practices at our student mine. This year, our members will have the opportunity to travel to Las Vegas, Denver, Colorado, and Australia.
Hi, I'm Robin. I'm a freshman. I'm a new member of SME, and I've been a member for about 2 months, but I'm already pretty involved. I go to all the meetings, and tonight I'm actually at the SME Tucson dinner, and there's a bunch of network opportunities and free food.
New members are always welcome at SME. We have meetings every other Friday at 11 a.m. in MNE 229. Hope to see you there.
The University of Arizona's San Javier Mining Laboratory south of Tucson, 250 feet deep, and the only student-run mine in the U.S. with a working vertical shaft. The mine provides a convenient location that can be used for training, research, and testing. It has been unchanged for decades, until now. The SX Mine is about to become an underground proving ground for mining equipment and innovation center by adding a new decline.
3, 2, 1. What you see behind me is the forward-looking nature of this mine. We're actually expanding this mine so we can bring in larger equipment, autonomous equipment.
The SX Mine provides a modern 15 by 15 feet decline, capable of accommodating small to mid-size mobile mining equipment. It offers the ability to operate underground mining equipment in a flexible, non-production setting.